Today we are going to talk a little bit about fraction basics, and this is the first session in a series of 6 small groups. This session is recorded to give you a little bit of a more understanding about equivalent fractions, how to simplify fractions, how to compare fractions, so that when you begin to add, subtract, multiply, and divide with fractions, you'll have a good understanding of the fraction basics. So let's take a look at the standards. Today we are going to talk about fraction equivalents and how to simplify fractions and create equivalent fractions. We will also talk about comparing two fractions with different numerators and denominators. We are also going to talk a little bit about mixed numbers and improper fractions because soon you will be computing with those. But let's start off with asking the question, what is a fraction? And the one thing that's really important to remember is that a fraction is a number. Here we have some pencils, and it says what fraction of the pencils are blue? Well, I can see that 2 of the 5 pencils are blue, or 2/5 are blue. We have a numerator on top and a denominator on the bottom. I hope that you listened to the story that was on the handout before you're actually listening to this recording, because that story talks a lot about the basics of fractions and some of the vocabulary. So if you haven't watched that, stop this recording and go watch that one first. Here we have a shape that's divided into 4 equal pieces. The key word is equal. When we talk about fractions, we have to talk about equal parts. One of the 4 pieces is shaded. We could also divide this shape into 8 equal parts, and we can see that 2 of the 8 are shaded, or 2/8. 1/4 and 2/8 are equivalent fractions. They both represent the same amount. It's also important to remember that fractions, just like any number, can be represented on a number line. Here we have the fraction 1/8, 3/8, and 7/8 represented on the number line. The denominator 8 tells us that we have 8 increments. We have 1, 2, 3, 4, 5, 6, 7, 8. Again, they're all equal. This 1 shows us that we have 8 of the 8. So if we hopped on our number line 8 times and it's divided into 8 increments and we hop all the way, we end up with 1. When you have the same numerator and same denominator, it's the same as 1 whole. I'm also going to draw a dot right here in the middle. This would be 4/8. What we're going to talk about today is how we can show this same fraction to be 1/2. 4/8 and 1/2 are the same amount. Even though the numerators and denominators are different, they still represent the same amount when we talk about the same size whole. So when we compare fractions and make equivalent fractions, we're always talking about something that's the same size. And we'll talk about that a little bit further as well. So let's go ahead and get started by exploring fractions with a few manipulatives. So I'm going to get out my document camera, and I have a candy bar because I love to use Hershey candy bars when I talk about fractions. And the reason I like Hershey candy bars is because they are divided. And right now I have half of a candy bar here, so I'm going to get my marker and write, this is 1/2 here and 1/2 here. Now, what if I said, okay, I'm going to give you a half of a candy bar and I'm going to eat half of a candy bar, but my candy bar was like this. It was a king size candy bar. My half would not be equal to your half. So that's why when we compare and talk about fractions, we definitely have to talk about the same size whole. That was also discussed in the book. When we talk about pizzas and pies and cakes, we definitely want to compare things that are the same size. You can also see that if I divide this candy bar into fourths, I have 4/4, which is the same as 1 whole. And you can always draw that little 1 to kind of remind you that you're talking about 1 whole. And also, in a minute, we're going to talk about how when we multiply and divide by 1, we don't change the value. So here I have 4/4. I can see that 1/2 is the same as 2 fourths. They are equivalent. So let's take a look at some more fractions. And I'm going to get a clean sheet of paper here. And this time we're going to look at fraction circles. And I have my one whole circle. And as we can see, all of my circles are going to be the same size. And this circle is divided into two parts. Here is one of the two, and here is one of the two. If I had two of the two, I would have the equivalence of one whole. But let's take apart this fraction circle so that I can see what's underneath. And underneath, I can see that I have a circle that's divided into 6 equal parts. When my denominator increased from a 2 to a 6, what happened to the pieces? The pieces got smaller because it's divided into more pieces. So we have 1/2 and 3/6. So in other words, I could say that 1/2 is equivalent to or equal to 3/6. What if I had 1/2 and I didn't know the comparison and I wanted to compare it to 2/6? And I would need to use a less than, a greater than, or equal than sign. Well, just looking at those two fractions without a model, you may say, I really don't know. So what we're going to do today is talk about how we can compare fractions. Now we can simplify them so that they are easy to compare. If we look at a model, it's easy to see, oh, here's 2/6. That's smaller than 1/2. So 1/2 is greater than 2/6. Now let's keep exploring. And this time, let's take away half of my 6th. I'm going to take away 3/6 or half. And underneath, you'll see that I have a fraction divided into 12ths. And again, as my denominator got bigger, the pieces got smaller. It takes more of them. So if I get my same sheet of paper out, I could say that 1/2 equals 3/6 equals 6/12. All of these fractions are equivalent. They show the same amount, even though the numerators are different and even though the denominators are different. Now this is what I want you to think about, because in 5th grade you start to add and subtract and multiply and divide fractions. If all of these equal the same amount, wouldn't you rather multiply and divide by 1 and multiply and divide by 2 than multiply and divide by 6 and 12? Multiplying and dividing by 12 is not the easiest thing in the world, but multiplying by 1 and 2 is pretty easy. So what we really want to do is talk about how we can simplify fractions in lowest terms, because 1 is definitely lower than a 6 and a 2 is definitely lower than a 12. And when we simplify fractions in lowest terms, it's going to make math and computing with fractions so much easier. So let's go ahead and let's explore a little bit about how we can simplify fractions. So let's move on to the next part, and I have a little fraction card here. And on this fraction card, I have 10/14. And maybe I'm supposed to multiply or divide something with that, or I'm just supposed to figure out what that really looks like. And drawing something with even 14 little equal parts can be hard. So I want to show it in the most simple way that I possibly can. So the first thing we're going to do is find the common factors. And we need to think about the number 10, and we need to think about the number 14. And we need to think about the multiplication facts and how you create a 10 and how you could create a 14. So if I think about 10, I always know that when you multiply, you can always multiply 1 by 1 and the number itself. 1 and the number itself are always factors. So that's the same with 14. 1 and 14. Now, I'm going to kind of do a factor rainbow so we can see this. I also know that 2 and 5 make 10, because 2 times 5 is 10. So they are both factors. And since 14 is an even number, I know that 2 and 7 create 14. So let's think about the numbers in between. 3 times something is not 10, 4 times something is not 10. So I'm finished with this one. Let's think about 14. 3 times nothing is 14. 4, 5, 6. So I'm also finished with this one. And as you can see, I found a common factor. I found something that they both have. So what I am going to do is simplify this number. So I'm going to divide to make it smaller. When we simplify, we want to get smaller, so we need to divide. And remember, if you divide by 1 or multiply by 1, the number's not really going to change, even though, as we determined with this, it may look different, but it still represents the same amount. Remember, our 3/6 is really the same amount as 6/12. It's just a simplified version. So, if we think about a fraction and we want to divide by 2, all we need to do is divide the numerator by 2 and the denominator by 2, and we will get 10 divided by 2 is 5, 14 divided by 2 is 7. 5/7 is equivalent to 10/14. This is my simplified fraction. So we simplified fraction. So we simplified it to be 5/7, but it's really the same amount. So let's try another one. Let's try 15/24. Those are much bigger numbers. I definitely wouldn't want to multiply and divide by 15/24. So I want to think about, can I make it in a simpler form? So let's find the factors of 15 and 24. You always need a piece of scratch paper when you're multiplying and dividing or doing 5th grade math in general. This is stuff that you just can't work out in your head. And you need to find the factors, find the common factor, and then divide by that fraction equivalent to 1 to come up with our simplified fraction. So let's do the factors. Again, we know that 1 and the number itself, 1 times 15 is 15. This number is not even, so I know that 2 or 15 is not divisible by 2, but 3 times 5 is 15. And then the only number left in between is 4, and 4 times nothing is 15. So I'm finished with that one. Now let's do 1 and 24. 1 times 24 is 24. This number is even, so I know that 2 times 12 is 24. I also know that 3 times 8 is 24, so this one has quite a few factors. And then I know that 4 times 6 is 24. So if I look at both of these, the greatest common factor, or GCF, there's nothing greater, is 3. So I can divide the numerator and the denominator by 3/3, or which is the same as 1, and 15 divided by 3 is 5. 24 divided by 3 is 8. 5/8 is equivalent to 15/24, but it is definitely much easier to add, subtract, multiply, and divide by 5 and 8 than 15 and 24. So we always want to find the greatest common factor, or GCF. Now, in a minute, what we're going to do is get a little bit trickier. And when we get a little bit trickier, we're going to do things with numbers like this. And we want to determine if a mixed number or an improper fraction is actually in simplified form, and how we can compute with those numbers. But before we do that, let's go ahead and compare fractions a little bit. So I'm going to get a clean sheet of paper, and I am going to get this little game that you'll also have access to, and it's skateboarders. And you can see that the skateboarders are working here, and they're starting right here in the middle, and they want to get to one of these finish lines. It doesn't matter which one. And right here it says if you compare two fractions, like we have two fraction dice here, if we compare two fractions, if it's less than, you're going to move to the left. If it's greater than, you're going to move to the right. So let's take a look at these two fractions that I have right here. This is pretty easy because they both have the same numerator. and they have different denominators. Remember what we discovered? When the denominator gets bigger, the pieces get smaller. If I have 3 of 12 or 3 of 10, let's say that you rolled this one and I rolled this one. And you can play this with a friend or a parent. You can each have a counter. You can even use a bottle cap for a counter, or one could use a penny and one could use a nickel. So we start here. Well, if this is the one I rolled, I'm going to have to move to the left because mine is smaller than this one. Then we could roll the dice again. So let's say we have 2/7 and 1/5. Well, those aren't quite as easy to compare. So what can we do to figure out which one is greater? One of the ways that I love to compare fractions is by drawing a number line. Now remember, the number lines have to be the exact same size because we can't compare fractions if we have different lengths. So let's divide 1 into 7 equal pieces. So we have, let's think about this. We have 1, 2, 3, 4, 5, 6. So our endpoints would be here and here. 1, 2, 3, 4, 5, 6, 7 hops. So 2/7 would be right about here. Now, of course, this isn't perfect because I don't have a ruler out and I'm not measuring them exactly. But now let's do 1/5. So let's divide this number line into fifths. So we have 1, 2, 3, 4. That could be our fifth little spot there. So we have 1, 2, 3, 4, 5. 1/5 or 1 hop would be about right here. So again, I can easily see that 2/7 is greater. Now I have to go back this way. And you can decide if you're with your friends or your parents if you want to skip all the way to the next one or have to go back to the beginning. So we would go back this way. So this is a fun game that you can play, and I know that you don't have fraction dice at home, but what you can do is get any block or any dice and just use a piece of tape or a marker and write different fractions. You can make sure the denominators and numerators are different on each one, and then you can use a sheet of paper to compare. But also remember, if the numerators are the same and the denominators are different, you can compare usually without a sheet of paper. I know that 1 of 3 pieces is bigger than 1 of 4 pieces. Now what if, let's see if I can find one that has the same denominator. And on these dice, I don't think that's true, but if there's the same denominator, then you can always look at the denominators. If I had 4/12 compared to 3/12, 4/12 would be more because I would have 4 of the 12 pieces instead of 3 of the 12 pieces. So this is a fun game to compare fractions, and it's also fun to be able to simplify fractions into lower terms, because when you simplify a fraction, like 4/12, I wouldn't want to draw 12 increments on my number line, but if I simplify that, I could see that it's 1/3. And so comparing 1/3 to 2/4, or we could simplify this by dividing by 2 or 3/4. So 1/3 to 3/4, we could easily compare those fractions. So this game is something I highly encourage you to investigate. So let's get back to looking at mixed numbers and improper fractions. Now in the story, it talked a little bit about this, but what we want to see is that a mixed number is something that has a whole number and a fraction. And an improper fraction has a bigger numerator than denominator. It's top heavy. There's too much on top. So what we can do is we can convert or change an improper fraction like this to a mixed number. And you'll see a lot of mixed numbers, and you may wonder, well, why does it matter, like if I have it this way or this way? Well, this is the simplified version. A mixed number is the simplified version because it shows the whole and the part of the whole. This one is not simplified, but it may be easier to multiply, divide, add, and subtract. So it just depends on the situation. So let's look at 5/3. I know that 5 is bigger than 3. So there's one way that we can do this. And let me get a sheet of paper out here. And let's draw a model. And let's draw something that's divided into thirds. There is my little bar, and I have 1, 2, 3, and then I'm going to draw another model of thirds, and I have 1, 2, 3, 4, 5 thirds. As you can see, I have one whole and then 2 thirds. So this fraction right here is the same as 1 and 2 thirds. Now after you get used to this and you understand that you can divide something into thirds, of course 3 thirds is what we have here, which is the same as 1. 3 thirds and 2 thirds equals 1 third. So if we wrote an addition sentence, we could see 2 thirds or 3 thirds plus 2 thirds equals 5 thirds, which is exactly what we started with. Now there's a trick that you can do, but it's most important that you understand what you're doing. You can divide, and you can say, let's have 5 divided by 3. A fraction is a division problem. And you may not think about that, but that bar right here means division. 3 or 5 can be divided by 3 one time. 1 times 3 is 3, and there is 2 left over. So our denominator still stays the same, so we would have 1 and 2 thirds. Exactly what we got over here, 1 and 2 thirds. That's the exact same answer. So remember, the fraction bar is a division problem. So let's look at another one. This time, let's look at a mixed number, 1 and 1/7. And the best thing to do when trying to convert a mixed number into an improper fraction is to think of this 1 just like it is a 7 over 7, because we have all of the 7 pieces. So if we add 1 more 7th, we're going to have 8 sevenths. So 1 and 1/7 is 8 sevenths. They are the same. They are equivalent. Let's look at a little more complicated one. What if we have 2 and 1/3? I'll turn my paper this way so you can see. 2 and 1/3. This time I don't just have a 1, but I know that 1 plus 1 is 2. And since my denominator is 3, we would have 3 thirds plus 3 thirds plus 1/3. 3 plus 3 is 6, plus 1 more is 7, and my denominator stays the same, so I would have 7 thirds. Now there is a trick, but again, we want you to understand the conceptual part, what it really means, before you just go to the trick. We are basically adding a whole and a whole and a part of a whole, because we have 2 wholes. So we have 3, 3, and 1. And the reason we have 3 and 3 is because we're talking about denominators of 3. But the trick would be, if I have 2 and 1/3, I could multiply and then add. 2 times 3 is 6, plus 1 more is 7, and my denominator always stays the same. I get 7 thirds whether I do it this way, or 7 thirds if I decompose and add it up. So either way works perfectly. So let's take a look back at our mixed number here, because soon in future weeks we're going to be working with mixed numbers, and we definitely want them to be in lowest form or simplified form so that they're easier to compute with. Can 1 and 4/24 be simplified? Well, I'm going to keep my 1 the same, but I'm going to think about the factors of 4 and the factors of 24. I know that 1 times 4 is 4 and 2 times 2, so I just need to write it one time because 2 is a factor of 4. Then 24, remember it had lots. 1 times 24 is 4, 2 times 12 is 4, 3 times 8 is 24, and 4 times 6 is 24. All of those are factors of 24. When I look at common factors, the greatest common factor, or you could say we want the least common multiple, I'm going to divide by 4. So let's simplify 4/24 by dividing by 4 over 4 are equivalent to 1. 4 divided by 4 is 1. 24 divided by 4 is 6. So technically, 1 and 4/24 is the same as 1 and 1/6. I would much rather multiply, add, divide with a numerator and denominator that looked like this than like this. So now that we've discovered fractions, we've talked about mixed numbers, we've talked about improper fractions, we've talked about equivalent fractions, we've talked about finding the greatest common factor and simplifying fractions. Let's take a look back at our big ideas of the day. One of the big ideas is that fractions can be equivalent or represent the same amount. 1/4 is the same as 2/8 is the same as 4/16. A fraction with the same numerator and denominator represents one whole. So when we multiply by 1 or divide by 1, we're not changing the number. It still is the same amount. It still equals 1. We can simplify and still represent the same amount, which is basically what we just said. We can divide or multiply by an equivalent to 1, and even though the numerators and denominators are different, they equal the same amount. And we also want to remember that a mixed number is basically a whole number with a fraction, and this can be converted into an improper fraction when we want to compute with numbers. So let's take a look at some other things. What we're going to do is explore the internet, and we are going to check out some resources that are available to you. So I'm going to open up the internet, and I'm going to reduce this screen just a little bit so you can see. The first thing that is referenced in the handout is the math website that we have at GCA. So definitely take advantage of this and go to the fraction page. And on the fraction page, the very first section talks about fraction basics like we've talked about today. 30% of the Georgia Milestones assessment will be based on fractions and computing with fractions. You need to know the basics before you get into those word problems that require you to implement these things. So I definitely would explore. You can go review 4th grade skills. There are video links right here. All of these videos come from LearnZillion, so you can go directly to LearnZillion and watch those videos. There are also study jams on fraction basics, equivalent fractions, and comparing fractions. There's also a little bit more here, video tutorials on equivalent fractions. There are games that you can play. There are fraction strips that you can print out. And then you can also begin to scroll down a little bit and learn a little bit more about mixed numbers and improper fractions. But the most important thing is to go over this top section that talks about the fraction basics, and definitely feel free to go back to 4th grade because those fraction concepts will be used again this year. The next site that I want to point out to you is Triumph Online. In your Triumph account, this is a mock student, so yours won't look exactly like this, but you will see a lesson right here on equivalent fractions, and you'll see lesson 18 on improper fractions and mixed numbers. So let's take a peek. You can go to Start, and what happens when you open that up is the lesson will appear. The first thing that appears are just tutorial pages, so you can scroll through those pages and review. And then the most important thing is if you scroll over, you will see a practice page, and this will test your understanding to see if you need a little more review on that or if you're ready to go. So what you can do is just scroll through the questions and click on the answer. So here we have 1 whole, 2 wholes, and then 1 of 3. So our answer, and it's not showing up right now, the internet is a little slow, you can see it spinning, but you would select 2 and 1/3 for that model. Some of the questions as you scroll down are going to be open-ended type questions. So definitely try your hardest, because on the Real Georgia Milestones you're also going to have open-ended questions, and some of them may be part A and part B, just like you have here in Triumph Online. So take advantage of the math website and the Triumph Online resources. And we hope to see you in class next week. This is the only session that is recorded because the teachers have professional development. The sessions will be each Wednesday, and there will be 6 in a row so that you can build a very deep and strong understanding of fractions. Thank you for watching, and we hope to see you in class.